Okay, so hopefully the pause worked exactly the way I wanted it to. We'll see when we're messing with this later. So I'm gonna do my best to. Y'all can't really see this. I got my five game pieces. That's all I'm trying to show you. I got my five game pieces, and what I'm going to do is do my best really to kind of recreate what we would be doing in a classroom setting. Ideally, I would have someone with me to be able to randomly draw these. But the way that we're going to do this is I'm going to hold the five game pieces in my hand. I'm gonna cup them in both hands. I'm gonna shake them up. I don't know what's going on in there. And then I'm gonna close my eyes. I'm gonna randomly draw one. It sounds kind of goofy, but I think this is the best way that we can make this work. And we're gonna do this a total of 5 times. Okay. Remember that it is literally possible to draw the same game shape 5 times in a row. But when we're talking about probability, there's a 2 out of 5 chance that I'm going to draw a circle, 2 out of 5 chance I'm going to draw a triangle, 1 out of 5 chance I'm going to draw a square. And that's what we should see happening. I want to emphasize that language about probability and what we should see happen. Now, as I shake these up, I'm going to close my eyes. I'm going to randomly draw one. All right, so my first game piece, just so y'all don't think I'm lying by nothing, is a triangle. Now I'm going to record on my screen through some of these tools. I'm going to record how many triangle pieces I get, how many square pieces I get, and how many circles I get. All right, we're doing this 5 times. My first draw was, I'm going to put a tally for one triangle. I'm going to put that piece back. Y'all better not think I'm lying about this. I'm really doing this. I'm going to close my eyes. I'm going to shake them up. I'm going to draw another game piece, a circle. All right. I'm going to put one tally mark down for circle. I'm putting it back, shaking them up. I don't know what's happening. Another circle. Close my eyes, put it back, shake them up. Don't know what's happening. Another circle. And then we've already done 4 draws, so we're going to do one more. Close my eyes. I put that piece back. I feel so foolish. Another circle. That's okay. I could feel foolish. All right. So I'm going to stop at 5. And remember, I wanted to stop at 5 because that's the total number of times that we could draw a piece, right? There are a total of 5 game pieces. And there's 5 possible outcomes. So I'm just going to stop at 5. So what we have just witnessed is the difference between frequency distributions versus probability distributions. In the probability distribution, I know it might sound kind of like a broken record at this point, but what we should have seen was that 2 out of 5 times I'm getting a circle, 2 out of 5 times I'm getting a triangle, 1 out of 5 times I'm getting a square. Based on frequency distribution and actual observations, however, what we see happen is that I drew a triangle once, I didn't draw any squares, and then I drew circle 4 times. Now, that's really all I want to do with that data is just emphasize the difference between a frequency distribution and a probability distribution. Frequency is what we actually observe. Probability is what we should see happening. I'm going to fast forward through these different points on this slide. How do I? Oh, here we go. I'm going to erase. Okay. Oh. In that last piece about graphing the results, if I were to, I'm going to move back a couple slides here just so that we can compare what we saw happen in our data, right? Remember that this graph here on the right side of the screen represents a probability distribution, what we should have seen happen. If I were to draw my data in here, that is the worst straight line I've ever drawn. That's okay. This would extend all the way up to 5. This would extend only to 1. And then this would be empty. And so we have a different kind of distribution, a different kind of graph that we represent with the data that we've drawn versus what we should see happening. I just really want to emphasize that point. Okay, let's continue. All right, so notation for frequency versus probability. So in Module 3, variability, we learned that S squared represents variance while S represents standard deviation in a sample distribution. We also learned that sigma squared represents variance and sigma represents standard deviation in a population distribution. So the notation for frequency and probability distributions actually follow this same exact pattern. So for frequency distributions, we would use S and S squared to represent standard deviation and variance, while for probability distributions, we would use sigma and sigma squared to represent standard deviation and variance for a probability distribution. Okay, so the likelihood of us having, actually truly gathering population data is so statistically improbable. And so we use population data at times almost like our theoretical data distribution. Okay, so that's I want you to conceptualize probability as this theory, right? This theory about what we kind of should see happening.